So, welcome to the second 10x live stream. Today I'm going to talk about the parser. It's something I've been meaning to talk about for quite a while. I keep saying I'm going to blog about it, but then not. So I thought this would be a good time to take you all through what it is, how it works, and why I wrote it the way I wrote it. So, one second. So yeah, what actually is the parser? So in most IDEs and editors, you have features such as goto-definition, autocomplete, finding references, renaming stuff, and it's the IDE knows about the language you're using and can assist you and help you to write your code, which I think all of us know. In Visual Studio, it's called IntelliSense. Never quite worked out why. It's not intelligent or sensible in a way. Also, you've got Visual Assist, which is a great product. And other editors have other solutions such as regex-based solutions, which will just parse the files kind of as text and pick out keywords, and you can kind of get some autocomplete using that, but they often don't know about the actual language, so they're slightly different, not quite as powerful. So the 10x parser is like IntelliSense or Visual Assist. It knows about C++ at the moment, and it parses the entire code base and then gives you all the assist features. So yeah, I was going to say about the way I use my IDE. Let's change this view so you can see it a bit easier. Okay, so I pretty much basically use only two features of any kind of solution like this in Visual Studio or whatever editor I'm in. One is goto-definition, which I have on Alt-G always, and the other is basically just autocomplete. So autocomplete. Those are pretty much the only two features I ever use. And when I was writing 10x for myself primarily, there was no point writing an editor if I didn't have those two features for me. For everything else, I use fast find in Visual Studio or my search panel here. And for example, if I want to go to a function, I'll just do, I'll type it badly, that, and then go straight to the function like that. I just find it much easier to do search like that, just put color in front of it, and function name, jump straight to it. And that's how I navigate the code. That's how I get around mostly. So those are the three features I just absolutely needed in my editor that I was writing. The question I'm often asked is, why didn't I go with an existing compiler solution such as LLVM or Clang or something like that, instead of writing my own parser? And there are a few reasons for that. One is it just wouldn't be fun, basically. Using such an advanced and complicated solution such as a compiler to do this. I'm sure it can be done, and I'm sure that's how lots of other existing solutions work. But that's not my idea of fun, trying to beat a compiler into submission to make it do what I want to do and extract the information I need. I mean, it may be that is the best solution, but I wanted to try something different, which I'll be explaining about my parser. The other thing is, I mean, all solutions I've come across, they kind of tend to fall over on really large code bases, such as UE4, Unreal Engine. a code base with millions and millions of lines of code. Often parsers will work fine up to a point, and then suddenly you'll get a really long stall, or it will just, for no apparent reason, just stop working, or just crash in the background, and then you've got nothing and you're without anything. They tend to be quite brittle. They're great when they work, but they just stop working for no apparent reason. So I wanted something much more robust than that. And what was I going to say? Yeah, for solving this problem of the editor knowing about the code as you type, you really need something that is parsing the code as you type it and updating instantly. So if I'm writing code, I just want it to parse that little bit of code I've written and then be able to use that. So if I write I want to be able to use A instantly. I don't want to have to wait for it to parse the entire file and then work out what it is, and then a few seconds later, come up with the answer. Especially if you've got a massive, huge file, it can really take quite a bit of time, and I want it to update, there and then as I'm typing. So this problem, I think, personally, is a slightly different problem than parsing code to compile it and generate bytecode or whatever. So that's basically the reason I decided to write my own parser, or basically just see if I could originally. So I set out to write this parser as a prototype because I didn't know if it was going to work. I mean, when I started writing the editor, like I said, I wanted to write my own editor, but I knew I needed the features of goto-definition and autocomplete, and I wasn't sure if I could actually write a parser to do that in a reasonable amount of time. So what I did was I wrote a prototype, and I just wrote it as quickly as I possibly could with very little upfront thought of how to do it. So I do have some experience with writing compilers. I should say before I go on that when I was at uni, I wrote a part of the course was writing a C compiler front end, which it was quite funny because at the time I thought this is a complete waste of time. I'm a programmer. I want to use a compiler, not write a compiler. When am I ever going to use the knowledge I've got about how to write a compiler? So at the time, I enjoyed it, but I thought it's kind of useless. I'm never going to need this. But it turned out it was really, really useful. So after, in my first job when I was working on a game called Sudeki, and it was a kind of RPG game, and we needed a scripting language, and I decided to write my own scripting language. It was a very simple language, and it compiled to bytecodes, and it was kind of like a sort of simple version of C, or kind of a cross between Lua, Python, that kind of thing as well. And it was a dynamic language, and I don't think it had strict typing, although I think you could, and it hooked in very nicely to the game engine. And everyone seemed to really like it, and the whole game was written in that, all of the quests and everything. And it was great fun to do. It was so much fun writing a language. It was something I'd like to do again one day. But that was just a simple language, but it did have a grammar, so I wrote out formal grammar for it and used the Yak and Lex tools and things like that. So yeah, I have experience of how to write a compiler properly and how to write a grammar properly. But I decided to throw all that away and not use any of that and literally just write it in C++ code in the most obvious, simple, basic way possible and just see how far I could get. And so the original was just a prototype I kind of threw together just to see, could I get something that was vaguely usable and useful and does what I need? And surprisingly, it went quite well. And I'm still actually using the prototype code as usual. If a prototype is good, you just carry on using a prototype, and then it never stops being a prototype. But it does need work, and the code is it's not my not my best code, and it's not structured in a good way. I think it does need a big refactor, but it's kind of working well enough for now, and I'm kind of really pleased with how it's gone for such a kind of straightforward approach. Right, what should I say? Okay, so let's just jump into the code. Why not? Actually, let's go. Before I do that, let's try something. Let's see. So first, obviously, you've got the lexer, then what I call the parser, and then what I call the def parser, which we'll get to. So the lexer is just a standard thing. It just tokenizes the code. So keep that in mind. So the tokens, I've just got a big enum, all the tokens. So yeah, tokens are just things like numbers, strings, keywords, etc., all the usual stuff. And it's very basic to just parse the code into a list of tokens. Now I store everything as arrays of strings, so one string per line. And then for each line, I also have an array of tokens that match up to that. The token just stores its offset, length, etc. So all fairly standard. Nothing that complicated there. The tokens I use are kind of just based on what I need and what the parser needs. So not anything C++ standard or anything. It's just, if I want to parse a class, I need a class token, etc. So this is just in no particular order. I just added things as I needed. Seeing if there's anything worth showing in here. Just got basic helper functions to parse numbers and hex and strings and everything. It's all just written as you would expect, I think. So let's move on. So the parser, how can I explain this the best way? So I guess the first thing I should say is that the parser knows about scope. So, if you've got namespaces, nested namespaces, etc., and then a class, and then a function, the first thing it has to do is just parse the curly braces and know you're inside a scope, inside a namespace, a class, etc. So it builds up a hierarchy of what I call defs or symbols, def for definition. And the way it does that, I've just got this horrible if statement, which just says, is this a preprocessed line? Let's go to that one. For example, if it starts with a preprocessor hash, it's a preprocessed line. Very, very simple. Otherwise, see if it's a see if it's a namespace. Otherwise, see if it's a class or definition struct. So it literally just goes through the code on every single token and says, is this something I recognize? So it's kind of almost a top-down parser rather than bottom-up. And the nice thing about this is it's very robust. If it comes across some code that it really doesn't understand, for example, like a lambda, it will just ignore that line or ignore those tokens that it doesn't understand until it comes across something that it does understand. It knows about a type definition, for example, a keyword followed by another keyword. That's a type. And it'll just assume, yeah, that's a type definition. And it will just go through every single token and say, is this something I recognize? And unlike a kind of formal grammar, which you usually use for writing a compiler, you usually have, what's it called, LR1 grammar or something, where it means it has a look ahead of one token. You can have LR2 grammars that look ahead of two tokens. So you kind of formalize a grammar so that you can tell exactly what each token is by looking ahead one or two tokens. Well, the 10x parser has n look ahead. It can look ahead as much as it likes. So if it's parsing a function, it will just check, is there a return type followed by option the class, and then a keyword, and then some comma separated variable definitions, and then a closed brace, and then a open curly brace. And if it finds those things, it will say, hey, this looks like a function, I think it's a function, and then it'll add that def, and then carry on with the parse into the function. So it's really nice, it's really robust, and if it finds something it doesn't understand, it won't break or crash or anything. It'll just throw up its hands and just carry on regardless and say, hey, is this something I recognize? Like something I recognize, and then hopefully parse it. So it doesn't always get it right. Sometimes if it really doesn't understand a bit of code, it will totally get it wrong and say this is a variable definition when really it isn't. But that doesn't happen that often, and I'm gradually, bashing those on the head as I find them. I did have one problem the other day actually where I had a sorry, I'm right in the middle of changing stuff in the parser, so bear with me if I have a few crashes. So, what was I saying? Yes, I had. This is not going to work. I should have tested this much more. I'll go back to the other build. Never show code you're working on at the time if you're trying to demonstrate something. Well, if I looked at what I'm doing, I think we're back. Yeah. Sorry, I'll get to your question in one second. I'm just going to finish this before I totally forget what I'm doing. So I had some code like this. And the parser doesn't currently know anything about preprocessor. I just haven't written a preprocessor yet. It's one of the major things I want to do. Let's make that bigger. So again, it just literally ignores this. And the problem was, it got to here and said, hey, that's a keyword, and then it had a member, and then assigned to 0. So because it was ignoring these two things, it just said, oh, I think this is a variable definition of type whatever. And so it was missing any code which had a define before it. Anything else was fine. That was parsed correctly, but if it had a define like this in front of it, it would just silently fail and think that was a local variable. So obviously that's why I added the define bars. Now it just totally ignores that line and it's fine. It knows what it is. So it does get it wrong sometimes. And it's just a case of whenever it does do something weird like that, I just go in, fix it, and it's usually a really trivial fix to do. It's just going to take some time for it to stabilize and get more robust like that. Some questions. What sort of data structures do you use for the text itself? I'm currently reading some different opinions on GAT rope Parser. Okay, yeah. Yeah, I don't use any structures really. I literally just use an array of strings, one for each line. It's funny because before I started 10x, I read about all the different things that are often used in editors and like rope structure, etc. And they all seem very complicated. And it seemed to me they were left over from the days when editors were written and had to work in a few hundred K of memory, It's really not that important to optimize the structure you're using for the code these days in any clever way. I mean, you've got to break it down into some form, so I just break it down into lines, and I've never had a problem with that. I'm going to break it. Yes, so someone's asking about have I set up any tests for the parser itself. I do have a test for it. Let's go back to Visual Studio for a moment. Where is it? CPP parser test. I'm not going to run it now because it's probably not going to work. But basically, I've got a Python script because 10x supports Python scripts, and it loads up a test solution, and then let's load up test solution. Test. Let's go on this was at the top. I was just testing stuff earlier. So yeah, it's got a load of markers, and the Python script just says go to this marker, and then say go to definition on something, and it checks it ends up at the right marker. So it will just do go to definition, it will find the definition, and that's where it should end. So it just checks that it's on that line. I haven't been keeping it up to date, to be honest, and I really must do. I really must get back to it and write more tests. Let's go back to the code. Yeah, but these are the tests I've got, not particularly much yet. So it just checks the basic things and runs in a few seconds, which is quite nice. But yeah, it's definitely something I need to expand because it's quite easy to break the parser in a way without realizing. So yeah, it's a good thing to do. Someone's had problems with hashif in enum, so it breaks the parser for enum values. Yeah, that should be fixed now. So if you get the latest version, it should be a lot better. I really must write the parser one day. Sorry, the preprocessor. It's not something I'm that worried about because running a preprocessor is pretty much a solved problem. You know, it's been done a million times, and it's not that hard to do. It would just take probably a few weeks to get done, and then that will really help because I know a lot of code bases do still use a lot of macros and if-defs and stuff like that, and yeah, 10x will struggle with that sometimes. So I mean, it will just ignore the if-defs and just pass the code as it's written. So hopefully it won't be too bad, but the macros are a bit of an issue. So it'd be really nice when it understands macros. So let's go back to what I was taking you through. My big horrible if statement. So yeah, like I said, just goes for each line, sorry, each token, and says, is it something I understand? So let's look at parse namespace. It's really, really simple. So if it's namespace, which is the actual namespace, if it's one of those, so it has this iterator. So as I say, I store everything in lines, which is a really weird way of doing it. If you're writing a compiler or something, usually you just treat the whole file as one continuous thing, just a one-dimensional array of characters, and you just parse it that way. But I like to write things in the way my mind thinks about them. So everything in 10x is written as a line array. So for the text editor, I just store everything as a line array, a string array of lines. And I do the same thing for the parser. And some things are a bit weird because you don't really care about lines when you're parsing code. But I've got an iterator here, which I can literally just start at any point. It iterates over and it doesn't care about the lines at all. So I can treat it as a single dimensional array of tokens. So you pass in the iterator where it is. It says, is it a namespace? Yes, then move next. If it's not done, because it might be at the end of the file for some crazy reason, and it's a keyword, so pure dev there, it's a keyword, then set the name of the namespace to that, so just store it off in the local. And if we're still not done, and the next token type is an open brace, then we're in a namespace. It's as simple as that. So that sets a scope. So if I'm in a child namespace like this, for example, I've got to know that I'm in a parent namespace, so I keep track of the current scope. And this set scope actually, so what I have is, difficult to explain. So I store everything, like I said, as lines, and each line has an array of tokens, obviously. And each line also has information about the what I call the defs. So this says, okay, set the scope of, say, for example, this namespace, sets on each token, it sets the scope, which is just an int identifier, to be the pure dev scope. So I'm building up, as I pass through the lines, I'm building up a list of tokens first for each line, then I'm building up some information about the scope for each token, then I'm building up some information about what the actual thing is. So here I do a create def, so everything is a def, so a namespace is a def, a function is a def, just short for define, one of the few cases where I use a shortened name. So I do a create def, so I'm creating a define for, say, this pure dev namespace. And that's just a class that stores information about that namespace. And it can have child defs as well, obviously. Passes in the parent scope. And I won't go into that for now. Yeah, does a bit of bookkeeping stuff and then returns true. So in this if, returns true, and then just carries on, goes around the loop again, finds the next token. If I don't know what it is, then I still need to set this scope. So if I pass something, I've no idea what it is, I'll still set the scope to be the current scope for those symbols or defs. So that is, go back to this, that was the second stage. So this is parsing classes, functions, etc. And the scope. So it builds up all of this information for all of the tokens in all the lines. So for example, this line will have 2 tokens in it, and it will say the scope for this and then the scope for that, and it will say this is a namespace def. So for each token, it can be a type. And these are all of the types. I've got quite a long list now. So for example, it can be a number, hex number, string, etc. It can be a namespace, it can be a class, it can be a function, it can be a member function. So I'm just going through code, building up a list of what every single token is and its scope. And that's pretty much all you need in a way to get the information you want. Then it's just a case of organizing it and cross-referencing it. Question, is pause break key supported in key binding? So any luck with it? I'm not sure what you mean by that. Is this for like cancelling a build or something? That should be supported. So yeah, I think pause break should be supported. You should be able to bind stuff to that key. If not, let me know, and yeah, let me know if that doesn't work, and I'll take a look at it. But it should be working. Right, so let's go back to the def parser. Not a very good name, the def parser, I must rename that. So this is basically for syntax highlighting, go to definition, and it's kind of like these two are bottom-up stages, and this one is a top-down stage. So essentially what the def parser does, I'll show you code, and this is where the most complicated bit comes in. Yeah. So when I click on some code and say go to definition, I then essentially call this getDef function. So it says what basically is this token, and what it does is it kind of works backwards. It kind of parses backwards. So these, as I explained, are fairly simple. They just run through the code, building up information as they go. This one, you ask it what to do at a certain point, and it tries to work it out a bit like a human would. So, for example, this, say I wanted to go to definition on parseRed token iterator. What it has to do is it has to work out its current scope. In this case, it would be the global scope because it's just a member. So the set scope function would have said, yeah, that's just the global scope. And then it has to say, well, in the global scope, is there a class called this? Well, that's simple enough, but there won't be because this is in nested namespace. So what it has to do then is it has to look at the file and say, okay, have you got any using namespace? This is just how I like to structure my code. Okay, yes, it's got a using namespace, puredev. So look in the puredev namespace. Has it got a parse thread token iterator? Oh, no, it hasn't. Okay, look at the next one, 10x. It looks in the 10x namespace. It won't be able to find the 10x namespace because it's not in a global namespace. So then it checks all the using namespaces above and says, oh, I've got a puredev namespace that has a namespace called 10x. And it finds that and says, oh, have you got a child called this? Yes, I have. And then we go back and that's where we are. So those are that's the kind of way it works. It works very much like you or I would work out what something is. And this is the monstrous get-def function, which is highly recursive. I don't usually like recursion. I try and avoid it wherever possible. But in a parser, it would be impossible to avoid recursion. So rather than just randomly scrolling through, let's try and find something that's interesting to talk about. Recursion guard scope. Yeah, this is the one thing about writing a parser to parse code that is being written is the code that's being written can be wrong, but the parser's still got to carry on and work things out. And you can create invalid code, and if you run a compiler on it, it'll just stop when it gets to something it doesn't make sense or something, and then give up. That's what most compilers do, and that's fine for a compiler. But for a parser, for an editor, you've got to cope with wrong code and carry on regardless, and carry on parsing the rest of it and to give you IntelliSense, because you're trying to give the programmer something where they're right in the middle of writing code. They might have half written a function or half written a class and not finished it, and it doesn't make sense to a compiler, but you would still like it to parse that the best it can and give you the autocomplete and stuff like that and go to definition. So this recursion guard scope was something I needed because a lot of the time it would just parse broken invalid code, say I can't think of a good example now. It's quite complicated how you can have code that goes into a recursive loop if you're doing recursion on get definition. So you get definition of this type. Oh, I need to find the definition of this class. And oh, that class is actually parsed as another type somewhere else. And you get into these weird cycles just because the code is half written, So I had to put in this guard to say, okay, if I'm calling get def on the same def if I've already done somewhere further down in the scope, then just bail out and give up. It doesn't happen very often, but it's something that obviously is really, really needed. Question. In the code base I'm currently using, I think goto works about 50% of the time. I think it's due to using includes outside solution. Yeah, that's something I've been working on. For the new 10x workspaces, which instead of using a Visual Studio solution, you can now create workspaces in 10x and create the project tree structure yourself. I've added additional includes. I'm not going to show you that now, so I have to jump out of that. Anyway, in the properties, you can set the includes, and the parser will parse everything in those include paths, and that works quite well for like external libraries or anything. I did have the great idea of adding in the includes for a Visual Studio project automatically. That'd be great. You want all the things that can parse it. But unfortunately, the Visual Studio includes brought in all of the Windows header include directories, literally pretty much all of them. It was about 2,000 or 3,000 files, huge header files, and loading up a solution took about 5 minutes and about 15 gig of memory. And it didn't understand a lot of the Windows header files because of all the defines and stuff, which isn't supported yet. So that wasn't a great idea, but ultimately I will be supporting additional includes inside Visual Studio solution files. I think I need to do a big refactor on the code so that it knows about include files and only pulls in includes files that are actually included, rather than just blindly pulling in all the files in the additional include. It just pulls in the ones you actually include, which would be much more sensible. It's just something I haven't done yet. So yeah, that will be supported soon. Yeah, so let's go back and talk a little bit more about the getDef function. So it checks for an indirection first. And this is what I mean by being highly recursive. So say I was getting the definition, goto-definition on this getStringID function on the string table. The getIndirection-def starts the iterator here and just walks back and says, is the previous token period or an arrow? And if it is, then is the next token a keyword? If so, then it's an indirection. And it'll call findDef, which indirectly calls this getDef function on this class. So getDef on this scans back and says, this is an indirection, and then it will say getDef on that. Once it's got the def of that, then it can use that to look inside and say, has this def got a child called stringID? Yes, it has, and jump to that definition. And obviously you can have any number of indirections going back. And it also works on namespaces and stuff. So, if you had some calling a function like that, it would say a previous one is double colons, that must mean it's an indirection. And so get the definition on that, it will find my namespace the same way as I described earlier, and then it will find that in this def. So as you can see, it's highly recursive, and you can have any number of levels deep to try and find what the actual define is, what the actual def is. For example, you can have 3 deep, 4 deep, and then you might even find that because let's go back to this good example. So yeah, when it gets the def of string table, it will first look up the member and say, is there a member in this class that I'm currently in? CPU class thread called string table. Yes, there is. It's here. Then it will say, oh, this looks like a member variable. Well, it already knows it's a member. It's a variable definition. So then it says, get me the type of this. And it says, oh, it's a W string table. Oh, what's the type of that? So then you have to essentially call getDef on that, and it says, oh, that's a class. But it might even be a type def. It might be that, for example, it's not a good example. Anyway, you get the idea. So it can be any number deep, and it's often really quite deep in the recursion. Question: memory is a bit of an issue too. Probably for solution using 11 gig. Yeah, that's not good. Yeah, the memory does need reducing. It's a really hard one. This, because there is just so much information. I think I wrote a blog on it a few weeks back. But there is stuff I can do. For example, at the moment, see. So here's the lines array, parser line. So it has the line text, has an array of tokens, line which we might talk about later. And each token is a sort of reasonable size. I'll try to pack it in, but so yeah, it's not tiny, but it probably doesn't need to store all of this for every file that you're not using, because it has which I'll come on later, is a database which stores all of the information. It doesn't actually need to store the information for every single file. It could either do it on demand when you open a file, or it could just cache it off to a file. So yeah, I mean, it does use a lot of memory at the moment. So yeah, for some UE4 products, they're absolutely huge. The one I'm testing on is just a simple UE4 one, but it still uses up a lot of memory. So, and the other thing I can do is add exclude filters. So there's a lot of stuff you probably don't need parser to parse, and I can just add a simple exclude to not parse those files. So there is a lot of stuff I can do, but like I said, because this parser was originally a prototype, I do need a bit of a refactoring to think about it, the structure of it a bit more, because it's a little overcomplicated, and I think it can be simplified and reduced down. So I'm not too worried about that. And because 10x is a 64-bit process, you can use all that memory. Obviously, it's not ideal, but at least it won't crash. I mean, most people who are running Unreal code bases usually have a beefy PC with a lot of memory and a lot of CPUs, and yeah, you can kind of get by with it, but it's definitely something I want to look at. Okay, so let's move on. So the third stage, def parser, does what I was just talking about. It calls the get def on the well, what I should say is when you're saying go to a definition on a keyword, essentially it will call that get def function and work it all out there and then. And it can do that really quite fast. But what I actually do, because I want the syntax highlighting, is on the third stage of the parser, I run through the file, and for every keyword that hasn't been parsed as a struct, class, function, whatever, there's still lots of things. When it parses a type, like this one, string ID name equals blah, it knows that that's a type, but it doesn't know the type of this on the second stage of the parser. It doesn't know the type at this stage, and it's only on the third stage where it does another scan through, and then it'll pick up the type for each thing, or at least try to. So it'll just say, it'll call get def function I'm talking about now on every single keyword. It'll just scan through every single keyword and try and find as though you've done goto-definition on it. And then it will cache that off. Again, that adds to the memory load because it's caching off everything at the moment. And it will store that in the token here. Where is it? So it stores the scope that I was talking about, and then it stores the def. So actually no, sorry, the def is for like namespace or class or function or whatever. The cache def is what is stored in the get def function. The reason it does that, because like I said, I don't need to. I could just call get def when you say go to definition. It would easily be fast enough, I think. But I want it for the syntax highlighting. So I want to know that this is a member function, so that syntax highlighting can color it differently from a normal member variable, a normal local variable, for example. So this is a local variable which I just colour white, and this is a member which I colour light blue. And I want that information. It's really useful for the syntax highlighter to be able to know a bit more about the code and make it obvious what something is. So when you see the parser in the output window, I don't know if it's going to show it here. It's just loading up the cache. So when it says updating syntax highlighting, that means it's going through stage 3, the def parser. So yeah, that's stage 3, updating syntax highlighting, and that's when you'll see the syntax highlighting pop in if you're doing a parser for the first time. And yeah, like I said, everything is cached off, so it writes the cache, and you can see how big of the cache is by looking in data, parser, and then for every solution or workspace you've got, there's this, and project cache functions. So for example, this isn't that big, 10x is just 365. No, that doesn't seem very big. I'm sure it should be bigger than that. Shooter game. Yeah, 2.4 gig for a shooter game, Unreal Engine project. So it stores a cache per project file. So is there a higher level structure before it has to go into the memory for the parse for a specific file? Not quite sure what you mean. If you could clarify that, that'd be good. Is there functionality I'd use it to define types for highlighting support in 32_T, for example? No, that's actually the next thing I'm going to do, because ultimately I want 10x to support other languages, not just C++. I picked C++ because that's what I needed, and it's the hardest one to do. If I can do C++, any other language will be pretty much easy compared to that. And the first stage of that is to, so the Lexa is to, instead of having all this stuff hard-coded in the Lexa, actually it does already have in 32T, is to put that out into a file that people can edit, and you can create ones for other languages that 10x doesn't support. And that will give you most of the syntax highlighting. You won't understand all the language stuff, like the member stuff I was just explaining, but it will, obviously syntax highlight all this stuff, which is what a lot of editors just do. So yeah, that's one of the next things I was actually thinking of working on, allowing people to customize at least the Lexa, and give support for most other languages in that way. So 104, there's a lot of stuff that isn't relevant. So if it didn't need to open the scope, that might reduce the memory load. And yeah, it's really difficult to know what's relevant and what's not from the parser's point of view. Like I said, I probably will add some exclude filters to exclude stuff that isn't necessary, like third-party libraries you might not care about. I'm not sure I've totally understood. Yeah, it's definitely too high. People talking about how much memory it uses for UE4. Rust support. I don't know about Rust support. We'll see. I haven't never used Rust. That's something I haven't looked into yet. But yeah, if once I've written this Lexa file, then people can add Rust support themselves, at least in the Lexa, and get syntax highlighting and stuff. And I'm kind of quite looking forward to supporting other languages in a way, because you can kind of build it up as you go. So for example, in the Python script, where did I have that? Oh, I don't know. It's gone. You know, if I want to support the parser knowing about functions in Python, it's very easy to say def keyword followed by another keyword followed by a bracket followed by some common separated args and then a colon. That's a function, and I can just easily quickly write one of these functions to do that, and then 10x will know about functions, and they'll go to definition, autocomplete and stuff will just work. So in a way, it's quite simple to add a small amount of support for any language. And obviously, there's a lot more to support with all the rest of Python, you know. But it should be quite easy to add a little bit of support for a lot of languages, just enough to make it usable and useful. And then over time, I can just add more and more of these and build it up as I go. That's the nice thing about this approach. I don't have to write a fully functioning compiler that understands all of the code and parses it bottom up. I can kind of just add bits as I go. And it's a much more flexible, sort of easy way to do it. And the nice thing is I haven't actually thought about most of these functions very much at all. Parse function definition, for example. I've literally just wrote this in a few minutes off the top of my head, you know, using the iterator saying next token, next token, next token. And it's not perfect, and sometimes it gets it wrong, like I was saying, sometimes it misses stuff, but in the majority of cases it does work. And I've spent very little time on the actual parsing of the code, and not much thought on it either. And I'm surprised it works as well as it does, to be honest. It was nice to find that out. So I'm happy going forwards. I can spend a lot more time making these functions more robust, making sure they don't parse things that they shouldn't be parsing, and ignore stuff and add stuff. And like recently, I added template support, which again wasn't actually as difficult as I was expecting. It was quite a nice thing to do. Shaders would be nice. Yeah, I want to support shaders definitely. How they would look treating shader code in C++. Like it quite a lot. I've actually done that in other editors that didn't have shader support. I just said treat them as C++. I think you can do that in Visual Studio, and it's pretty good actually. Gets most of it right. Okay, there's a Rust server which does the parsing. That might be nice. Yeah. So this whole parser is written as a plugin. So in theory, you could rip out the entire parser and replace it with another one. Just make sure you conform to the interface. And I may even open source it one day, and people can write their own parsers for 10x. That would be amazing. Save me a lot of work and a lot of time. Yeah, there's a lot of stuff that can be done going forwards, definitely. Okay, I'm not getting that far through. There's still a lot of stuff I was going to talk about. I've been going an hour, wow. Well, if you want to keep going, I will. Oh, you're planning wider support for plugin interface support. Yes, I'm going to open up the plugins so that people can write C++ plugins for it. At the moment, it's not quite there. I've got an interface which I use internally, but everything is just statically linked, so I need to add support for DLLs. And what I really want to do with the plugin system is allow support for running as a separate process as well. And also backwards compatibility, so that you don't have to recompile every extension or every plugin for each new version of 10x. So there's a little bit of work to do there just to make it really functional for people. But then I'll definitely open up the interface. At the moment, you can add support through the Python scripts, and I'm adding stuff all the time to the Python interface. And it's pretty easy to do, and I've got all of these functions. I'll post a text file of a list of all these at some point, and so that you know what's there. So it's quite hard to find. Is 10x planned for Linux? Mac OS? Oh, Mac OS, sorry. Yeah, definitely. Again, that's probably further in the future, supporting Linux and Mac. But as I was saying in the first stream, the whole engine was written to be cross-platform, to work on iOS and Android and Windows and stuff. So it should, most of the code should just work. I just need to add the Windows support for things like that. And I've heard it's a little bit tricky in Linux to do a Windows, support for creating windows and hooking in input stuff like that. But yeah, definitely, it's something I'm planning for right from the start, and making sure everything is as easy as possible in that respect. Yeah, so let's just look at my notes, see what else I was going to talk about. I think I'm going to miss that out for now, threads. So yeah, recently I added support for autocomplete in a global namespace. As I noticed that, what should we use? No, let's go to actually it doesn't matter. Anyway, so let's. Oh yeah, I'm not on the latest build, so it's not going to work. Let me just see if I can get the latest build working again. Yeah, it works. Okay, so yeah, I noticed that it wasn't auto-completing for stuff in the global scope. What it would do is, I mean, it would auto-complete stuff like that list because it's in this scope, and it would also autocomplete anything in this. So it is alphabet jar. That would have worked because it's in this file. Because everything, like I said, it's file based. For some reason, I just didn't think, and I was saying, okay, when I do autocomplete, when you're typing a word, it detects you're typing a word, obviously, and then it says, okay, you're typing a word. Give me a list of all the defs that it could possibly be. And then it filters it by, as you type, it will just filter that list dynamically. And it was checking the current scope, so finding, them variables. It checks. It starts off where you currently are, and then checks anything above that. It goes up through the file, through the function, and then it'll say, okay, is there anything in the global scope? And it'll go up to the global scope. And so it wasn't finding global stuff in other files. So if my string class, if I was to write double string, it wasn't working. And literally, I just literally forgot to go to the database and say, give me everything in a global scope. So that's really nice that works now. That's, I find that really helpful. Obviously, it does return a huge list, and I had a little bit of time optimizing that because, like on Unreal, it was returning 60,000 objects in the global scope. So that was a pretty big list. So yeah, that is what I'm currently working on, and I was going to do a drop today, but I'm probably not going to get it done. So that will be in the build tomorrow, which I'll release, hopefully, all going well. And yeah, okay. So memory-wise, it would only need things for the current file and global scope. That may mean that quite a lot will be swapped out anyway. Yeah, I mean, it's only using a small subset, really, of everything. Unfortunately, it's going to touch a lot of memory when it looks like the global scope. But I haven't actually shown you the database class yet. So aside from storing all that information on all the tokens and all the lines, so that's stored per file, I also have a global, what I call database, and that stores stuff for the entire code base. And where's so it has a def node tree, and this is essentially like you would see, when you see a sort of class breakdown of a structure, and you just have a tree structure of all the namespace classes, etc., and that's done across the entire file. So if you've got like a namespace that's like my pure dev namespace, there'll be one node for that, and then anything in any of the files will be added to that one node, rather than having 1,000 different namespace pure dev namespace devs. So really, yeah, it's probably only going, when you do autocomplete, it's only going to go through this, the local scope, and then this def node tree. And I also saw lots of other structures, what I call def node hierarchy map, and somewhere there's a function, member functions list. So I store all of this data in slightly different ways for how I want to look it up, because sometimes looking stuff up can be quite slow. So, for example, the def node hierarchy map, that takes a string, essentially, of the scope, which can be multiple things deep. For example, file system file, that would want what I call a hierarchy key. And that's a very fast lookup for give me everything in this scope, and then it can just get def nodes for that. So I store the data in lots of different ways, which it's not that much memory because it's just different maps and stuff and arrays and things on it, but it allows a very fast lookup in all the various different ways I want to look stuff up. Right. What else am I going to talk about? The time. No, I will carry on a little bit and talk about the multi-threadedness of it, because that's pretty much the most complicated bit of the parser. The fact that when you see it parsing defs for the first time and it's scanning through all the files in the project, it does that multi-threaded, so you should see your core count be utilized to its full. And that was a very hard problem to solve. So in a way, you might think it's simple because, for example, the lexer and the parser are pretty much like a compiler. So you can literally just have a separate thread per file and just do all the files at the same time. So that's pretty easy. This def parser is almost like a linker, and writing a multi-threaded linker is usually not done, and that's why link times are always so horrible, and it's a very, very hard problem to solve. So the reason is because of that recursive get def function I was talking about earlier, if you remember. So this def, as I was talking about, just goes for a keyword, says try to get the def for that, oh I need the def for that first, oh I need the def for that, and etc. And on it goes. And if you imagine you've got lots of different threads all calling this get def function on different files at the same time. So how I kind of visualize it is, for each, let's say that these are files. I always visualize things. I always think about things in a visual way like this. So, for example, if I'm you've got a thing like that, and you say, okay, what's the type of this P class, my class, and then it has to try and find my class somewhere, and that might be in a file over here, and then it says, oh, my class is a type def of something, and then it tries to find the type def, and it goes to a different file somewhere else, and then you've got other files. Sorry about my drawing. I draw, for some reason I use my mouse with my right hand and I'm left-handed. I don't know why I do that, but it's lost in the midst of time. So you've got another thread which is trying to parse something, and that might find something in the same file, or it might even find the same my class structure, or another thread might be coming along and parsing this one, and then I might need something in this one. And as you can imagine, it's a complete, nightmare of different threads all going to different nodes, potentially the same nodes at the same time, and it's complicated. And the thing is, what I needed to do, I needed a shared read-write lock class, basically, so that multiple threads can all read the same file at once. But because this file might be being parsed, I mean, maybe while it's parsing all this stuff, you're editing this file. No, I'm not going to try and write with my right hand. That's a bad idea. So you might be editing this file at the same time as all this stuff's parsing it. And obviously, if you're editing, you need to lock out all the other threads. So I used a shared reader-writer lock for that. So multiple things can read at the same time, but only one thing can write. But the problem was that because I was using the SRW lock in Visual Studio, and it's a brilliant lock. It's really, really fast, and it's great. It does exactly what I need: shared reading, single writing. But it wasn't recursive, and this mess of parsing in a multi-threaded way, it needed to be recursive. Like I said, I couldn't write that get-def function without it being recursive for obvious reasons. It was just been a nightmare. So I ended up having to write my own. I should be using 10x, of course. Recursive shared read mutex. And it didn't have to be particularly fast as long as the read lock was fast. I didn't really care about it otherwise. Well, I say fast, obviously it has to be really fast, but not as fast, it doesn't have to be as fast as a critical section or something. And basically you keep track of the threads that currently have a read lock on it, and don't allow a write lock until all those are done. And then you've got a few little problems like making it fair, so that making the write have higher priority. So if something wants a write lock, nothing else can take a read lock. So it's a little bit tricky to get working. And I've never actually come across a recursive shared read-write lock anywhere. I looked on the internet and there just doesn't seem to be such a thing. So it's a little bit of a fun task trying to write my own. I actually wrote it up in a blog. So if you go onto Pure Dev software blog, not the 10x blog, but the Pure Dev software blog, I wrote it up, and I actually gave the code out as well. And yeah, I've never had a problem with it so far, so I think it's safe. It's really hard writing these kind of lock classes to make sure they're actually safe, but I'm fairly happy with this one. So yeah, when you see it parsing, it will be doing all of this nonsense. All the threads will be going at calling get-def function at the same time, all over the code base, and you'll see the syntax highlighting update as it parses files. and it's really, really quick actually. I mean, you can do a whole parse of my Unreal game in about, I can't remember, it's somewhere between 30 seconds and a minute, which when you think about compiling and linking a whole Unreal Engine is pretty fast. And it uses up, it has very little downtime in the CPUs. They're all pretty much used at their maximum, so they're not waiting on each other too much. And yeah, it's pretty good utilization. Right, just looking at my notes, I think I've covered everything I want to cover. Obviously, there's a whole lot more to go into on the parser and how it all fits together, but I think I've given you a fairly good overview. And it's something, the parser is something I'll be updating as time goes on. So I want to be feature complete on the editor side of it. There are still a few things I need to do on the editor side. I haven't even got a finding files. I want to do a like Visual Studio's finding files function where you can actually just search any files on your hard disk. I mean, 10x doesn't actually have that yet because I hardly ever use it. But obviously, I need to do things like that to make it complete. What else do I need to do? A few other features that actually need doing. And then once 10x is feature complete, I can just concentrate on the parser for as long as necessary. And it'll get better and better over time, I'm hoping. So yeah, bear with it. It's getting better all the time, and I'm going to be adding support for more things, such as I haven't supported unions yet, but that's really trivial to support. So I'll be adding that hopefully next week. And bit fields as well, things like that I need to support. So a lot of this is done on an as-needed basis. I'm never going to be fully C++ compliant in my parser. It's just not going to happen. It's never going to understand everything. I mean, at the moment it doesn't even understand lambdas, but because lambdas are just functions within other functions, it just parses it. It ignores the lambda statement and just carries on parsing it, and actually works. It knows that this variable is from the outer scope because it doesn't actually recognize that it's a lambda. So yeah, I mean, if you let me know when you're using 10x that it's not parsing something you think it should, or you think it would be easy to parse, like unions, for example. I don't use unions that often, so I just haven't thought to add it. Just let me know, and I'll get it added. If it's a simple thing, get it added fairly soon. Like I said, the big one is the preprocessor, and that will add a huge amount. So that's the next big thing I want to do on the parser, other than just gradually updating it. So if you do find any bugs with the parser, do let me know. And what's really, really useful is if you can supply a simple test project or CPP file, which is self-contained and just shows the error, because if you just say in the Unreal codebase this doesn't work, that's actually quite hard for me to track down. But if you say, oh, if I have this define followed by a variable definition, then it just gets confused. Give me a very simple CPP file, and that's fantastic. I can just drop that into my test parser thing and instantly see it and get really fast turnaround on it. That's the nice thing about the parser, is usually you can get things working in a very small way, in a very small, just a single CPP file, and then it'll just work on a sort of 2 million line code base. But it's really hard to debug on a 2 million line code base, obviously. So what I usually do is I just try and find what's not working, then write a very simple test case, and then just iterate really quickly on that, and then just drop it back into the main project, and away it goes. So yeah, bear with me. I'm improving the parser all the time, and yeah, it's a big thing to do, the parser, but already I'm finding, at least on my own code base, that it's really useful and working as I expect. Like I said, all I use is goto-definition and autocomplete, and that's working really nicely now, at least for me. But obviously I know everyone uses editors in a different way, and everyone uses C++ in a different way. There are a million different ways you can use C++, and just because it works on my very simple, basic code base doesn't mean it's going to work for everyone. So yeah, do let me know if I know a lot of stuff isn't working yet, so only let me know if you think something should be working with what it's currently got. If it's just not working because of the preprocessor, then yeah, I know that, and I need to write the preprocessor. But yeah, I'm sort of relying on people telling me stuff that doesn't work, and then I just add it as needed. Because, like I said, I'm never going to be fully C++ compliant. Okay, so I've looked at questions for ages. Sorry, I haven't been ignoring you. Do you use all cores? I used to hate Visual Studio, used all cores and basically killed your machine. No, I don't. I always leave one core free. And I think I even added a setting for that. Maybe I didn't. Maybe I didn't expose it. Yeah, I'll expose a setting for it. But basically, it always tries to leave at least one core free. But because I've got multiple systems, if multiple systems running at the same time, like if it's indexing all your search files at the same time as parsing, then it might use all of your cores because it has more threads than cores. So yeah, but I've got a task manager which has a single thread per core, and it leaves one core free, so that should be okay. Have you considered adding a feedback system in order to I feel bad contacting you, small thing. No, don't feel bad contacting me. Contact me, please. I'm getting quite a bit of feedback at the moment, and I've already got a list from sort of 2 or 3 people, which is great, and it's going to keep me busy for a week or 2. But every bit of feedback I get, I log it into my big list of things to do, things to look at. So nothing ever gets ignored. It may take me a while to get to it, but everything gets added to my list. So I totally rely on people giving me as much feedback as possible. But yeah, like I said, I'm a little bit inundated at the moment with features and bugs, but that doesn't mean stop sending them to me. It just means it might take me a while to get to it. And what I tend to do is I'll look through, if someone sends me a big long list of things, I'll look through that list and see, is there anything that will take literally 30 seconds to fix? And a lot of things, you'd be surprised how quickly I can just fix simple editor issues like editing, or even like adding unions. I'm expecting that to take about 5 minutes. So if you say, I really need unions, let me know. And even if I've got a whole load of other stuff to do, if it's just a very simple thing to do, I'll just take 5 minutes out of my day and just add it in and send you a new build. So I tend to, first of all, prioritize by what's really, really simple and easy for me to add that will make it a lot better for you. And then I just try and prioritize by how many people have asked me for something, and also what I feel like working on. But yeah, I've got lots and lots to do, but what I want is feedback on what is useful for you, for the users that are using it right now. What would make it better for you and make you more likely to use 10x. And yeah, I'm aware it's going to be an ongoing thing over time. But yeah, so adding a feedback system, I definitely want to do that. It's something I've got planned, just haven't got around to doing yet. Just a little box somewhere in the top right or something where you can just quickly add a note and say this doesn't work, and that'll automatically get sent to me. So yeah, that's definitely on the cards. But for now, you can contact me via Twitter. You can email me. If you've signed up for the beta, then you've got my email. And if you're a subscriber, then you get access to the Discord list, and then you can talk to me directly and just send me stuff, and I'll reply. So yeah, there are lots of ways to contact me. Don't feel bad about contacting me, please. I need your feedback. So yeah, that's fine. Have I missed anything else? Excuse me. Okay, I think I'll wrap it up there. That was quite a long one. I was going to do a short one today, but Parser is a big topic, so I think it needed time. So unless you've got any more questions, I think I'll wrap it up. And yeah, do let me know if you want me to talk about any specific thing in the next stream. I don't know what I'm going to talk about next. I might talk about the parser a bit more, because there's still lots more I can go into. I could also go into some of my core classes, containers, go into some of the threading that I'm doing, or the optimisations and stuff. If someone asks for optimisations, I might do that next. Yeah, do let me know. So thanks for watching, and I'll see you next time. I'll probably do it on Saturday next week. So Saturday at 5 p.m. I think I'm going to plan to do. Great, yeah, thanks, no problem. I've enjoyed it. Okay.